much. It's great to be here. I'm going to talk about human language technology, which is basically anything machines do with text and speech, including automatically translating between human languages, question answering, letting you do hands-free text and email, device control, analyzing online sentiment, web search. The good news is that if machines can understand what we say in English, then they're going to give us lots of new capabilities. The bad news is machines are terrible at understanding natural language. So if you tell a machine olive oil is made of olive, peanut oil is made of peanuts, sesame oil is made of sesame, it's going to think baby oil is made of babies. It's not just the words we choose, it's the order we put them in. So we say why cats paint. That's different from why paint cats. So this is difficult for machines. A lot of it boils down to ambiguity. So take a word like interest, common word. Well, it can mean bank loan, it can mean concern, or part ownership. And the correct meaning depends on context, and there's an infinity of context. So interest in IBM, well, that's probably not the bank loan interest, a financial interest in IBM. So the more context that we have, the easier it is to disambiguate that word. And the amazing thing is people just do this effortlessly. So every word I'm saying, you're somehow figuring out what that word means. And it's not just strange words like interest, but even words like IBM have several meanings. So could mean the company, or could mean a spokesperson for IBM. Or if I ask you, where's IBM, I'm referring to the building or the headquarters. And so machines have a lot more difficulty doing this than people do. And we have to figure out how to program it. And not just that, but English is one language, but there's thousands of languages that we want machines to be able to deal with. And all these languages up here are spoken by more than 25 million people each. So, and once you start talking about multiple languages, then now we talk about being able to cross language barriers. So we want to be able to build software that can translate. So you want to take this text in Chinese or in Hausa that you probably can't understand, and we want to turn it into English that you can understand, and vice versa. So these are all the kind of difficulties that computers have in dealing with language. And so it's been a grand challenge for artificial intelligence for many years to try to build this technology. And people have gotten involved in this for a lot of reasons. So some people are just passionate about how human language works. You know, what makes a certain string of words grammatical and sensible, and another string of words just garbage. That's a kind of linguistic science. Other people have an interest in foreign languages. So what's the difference between English and Chinese? But down to the level that you can explain that difference to a computer, not just to a person. And other people have a desire to change the world. So we think, okay, how will the world be different when the language barriers completely disappear, when I can just pick up the phone and talk to someone who doesn't speak English and the phone translates? So we've been spending a lot of time in the laboratory working on these problems. And I would say, 15 years ago, 10 years ago, we had made a lot of progress, but still individual end users weren't using a lot of human language technology. But that's different. So today, lots of end users use the kind of technology we're building. So just some examples are Apple's Siri personal assistant that you can talk to, Google Translate, which is a freely available translation service on the web, news aggregation systems that many of us use to read our news every day. And I just picked on these three products because they came directly out of U.S. government-funded HLT, human language technology research. Not just the ideas, but the individuals who worked on U.S. government-funded projects moved to create those products. And, of course, those individuals were part of larger funded efforts that involved many research institutions and universities and so on. And not just funding for human language technology, but the improvements in hardware and software are key to driving all this research. So that's tools for individuals. Companies are also using this technology. So take a company like TripAdvisor, which collects up millions of hotel, restaurant reviews from people and lets you sift through them when you're planning a trip. They were very successful in the United States and wanted to get into new markets. So they wanted to, for example, get into the Spanish market. So how did they do that? They took all those millions of user-generated reviews in English, automatically translated them into Spanish, and created a site called TripAdvisor.es for España. And then Spanish people just logged in and thought, well, this is a great site. They could understand the reviews in their own language and started posting their own natively written Spanish material. And this allowed TripAdvisor to get into a new market, be successful. And the great thing is they could do that again for France, for Russia, and many other countries. Another thing companies are doing is companies like Intel, Apple, Dell, and Adobe. they generate lots and lots of, millions of help articles on the web. So you can go solve your own problem if you're using their products. You just log into the web and look at the frequently asked questions and so on. And this allows people to solve problems by themselves. They don't have to call up Intel on the phone. Every time Intel picks up the phone, it's $33 for Intel. And so they save that times millions of phone calls. It's a huge amount of money that they can reinvest. So now they're using technology to take all that English material that they've written and get it out, push it out in Spanish, French, German, Russian, Chinese, so that everyone else can also self-serve and don't have to cost them money that they can then reinvest. So those are tools for companies that this technology provides. And then finally, tools for military and intelligence. So here's a newscaster talking Arabic. So she speaks. There's foreign language speech recognition done. Her Arabic is typed out. Machine does rough translation to English. And then those segments are stored in a searchable archive. So an English-speaking analyst can go retrieve that material and work with it. This for analysts, for soldiers in the field. They're just now being able to use handheld translation devices to talk to people in the countries where they're working, Afghanistan, Iraq, and other places. Okay, so I started with a grand challenge and seems impossible, and then we wound up with some products that are actually in the hands of companies and military and individuals. So what's been happening that's been good? So one thing is, as a field, we decided to focus at some point on common linguistic phenomena instead of the obscure, super difficult linguistic cases that kind of fascinate academics or have fascinated academics for a long time. And we decided to have machines learn automatically from online text and speech data, to manage uncertainty with probabilistic models, to evaluate the accuracy of our system, so this is the engineering part, and in that case also to develop common tasks. So many people working in this science around the world can all come together and say, hey, we all tried to solve this problem, translating Chinese news articles into English, for example, and we can swap notes, and this has made the technology advance much faster, and the government's had a huge role in that. For example, NIST has been running annual evaluations on many different types of this technology. And then we refine our models and go back. So let me say a couple of words about the second bullet there, which is having machines learn from online text and speech. So I mentioned this problem of ambiguity. So I have an interest in gardening. I earned 5% interest last year. Zuckerberg holds a controlling interest. My interest is purely out of curiosity. Instead of programming a solution for every word of English, hundreds of thousands of words, what we've done instead is have human beings annotate these words and provide annotated data. So, for example, someone has said, I have an interest in gardening. Oh, that interest is the concern, fascination, sense of interest. Or the next one is the bank loan interest. And so once someone can annotate hundreds or thousands of these, and it's fairly cheap to do this, then a machine can start looking for patterns. And when a machine looks for patterns, it sees a new word, and right away we can say, hey, one of these senses of interest is much more popular than the other one. If the machine has to guess, it can guess. And so there's probabilities down there on the bottom of the slide. As the machine sees more context and can use what it's learned, those probabilities adjust themselves. So here it's decided that the meaning of this word in that context is part ownership because of the words around it and conclusions it can draw. And so this allows us to scale up to full vocabularies and better understand what words mean. Maybe a more interesting case is how machines learn to translate between languages. So here's a person at the United Nations translating. He and his colleagues have produced 1 million translated documents from Spanish to English. And then we let our learning machine loose on that data. The learning machine says, you know what, every time that person sees banco in Spanish, he either types bank or bench in English when he translates. But every time he sees banco de, he always types bank. He never types bench. So it's an interesting translation pattern. And the machine can look at not just that pattern, but millions, billions of patterns and come up with millions, billions of translation rules that it can organize for itself. So how does it do that? Well, we use these parallel bilingual corpora, Spanish-English. For example, here's a very small one. It's a bit too small to read, but it says Garcia and Associates, Garcia y Asociados. Carlos Garcia has 3 associates. Carlos Garcia tiene 3 asociados. So the machine sees this data. But when the machine sees data like this, it looks at it a lot differently. You and I look at this and we see, oh, this is English, I know English, and we can start to draw conclusions. When the machine sees this, it might as well be outer space languages. So when a machine looks at Spanish and English, it might as well be seeing Akvun Orarak Sprach is a translation of Atvun Bichat Dat. And it has to figure out, how do these words translate? So I just want to give you a little sympathy for the poor machine when it looks at this text. It's not like us. But still, the machine can learn a lot. So take a word, it's trying to translate this sentence up here. Take a word, Farok. What does that mean? I don't know what it means, but the translation probably appears somewhere in that sentence 5b or 7b. And in fact, the only word in common there between those two sentences is this other word, Jijat. And so the machine can hook those up, and say those might be translations of each other. And through kind of mathematical algorithms, the field is devised. We are able to hook up all kinds of words. We're able to determine when words should change their order under translation. And the machine can take all that and be able to translate new text. So, for example, here's a Chinese sentence the machine's never seen before, and you can kind of see how it's assembling an English translation. Taking bits and pieces of Chinese, translating them into English, and then assembling those grammatical bits into a sensible English sentence. This says that this phenomenon is particularly evident in the cold winter, and you can also see how the Chinese words change their order when they translate. And a lot of that progress has been driven by government-funded research programs. For example, the last 5 years has driven down the error rate for machine translation on Arabic newswire text from 15% to 5%, and making good improvements on news groups, broadcasts, and even talk shows. So talk shows 5 years ago, basically untranslatable. But now you can get a rough translation of what's going on in a foreign language Arabic talk show. And speech recognition error rates have likewise been coming down under nice support from various government agencies and evaluations run by NIST. Okay, so there's been a lot of progress in the field, but machines still make a lot of mistakes, and there's still a lot of things that we just can't do using natural language. And for the next round of innovations, what we need is to have the machines have a deeper understanding of what they're reading and hearing. So, for example, if a machine sees the sentence, Pascal was charged with public intoxication and resisting arrest. Right now, we're very good at breaking that, diagramming that sentence. We say, okay, Pascal is the subject and was charged with was the predicate. Okay, so Pascal was charged with something. But there's a lot more going on in the sentence, and we need to understand the deeper meaning, which is Pascal's doing a lot of things. She's being charged. She might have been intoxicated. She might have been resisting something. She was almost definitely being arrested. So that stuff is not overt in the sentence, and we need good methods to pull out that knowledge out of simple sentences like this. And again, you and I do that effortlessly, and we need to teach the machines how to do that too. Okay, and other things that I'd like to be able to do, I'd like to just tell the phone or tell the computer, ask that guy I had lunch with to send me the paper he mentioned. Right now, this is, it's a lot of email and a lot of it, you spend maybe a half an hour, 45 minutes trying to do this. You should just spend 15 seconds saying just that sentence that I said, right? Or drive me to that Italian place in Santa Monica. We're going to hear about cars that can drive themselves, but as soon as they start being able to drive themselves, we're going to want to say stuff like that to the car and be understood. Publish my story in Bengali. Okay, and one more thing. I think we need to not forget that there's lots of languages out there. There's something like 4,000 languages in the world, and I threw a few of them up earlier. I made a map here. The green countries here are ones where machine translation is working okay. So we can translate from French to English, Spanish to English. Swedish to English is surprisingly good. So there's that language barrier is slowly, dropping. But if you look in the parts of the world colored yellow, this is where the translation is, well, it's okay. It's actually surprisingly good. So translation from Arabic, we were happy to be able to develop methods that are okay. So you can basically understand what you're seeing when you're reading Arabic. But person-to-person communication is difficult. And as far as the red areas of the world here, machine translation is just not working very well at all. So Chinese English, particular Japanese English, Korean English, to say nothing of all these African languages that have hardly been touched yet by the technology. And so if we want language barriers to drop between us and all those parts of the world to enable personal contact, commercial contact, military contacts, then we have a lot more work to do. Okay, so that's it. Questions? We have about 5 minutes for questions. if we can get that back. So those are areas where a lot of English is spoken, so we can get by with English, or other ones that I just couldn't quite classify. Yeah, so that's been the revolution in our field, is using either large amounts of annotated linguistic data, online data, or even just naturally occurring data. So when we train translation systems, we pull our training data off the web, and we just piggyback on top of all the human translators who are doing their job every day, and sort of watch them and learn from them. So that's been the big revolution in our field, and I think that's not going to go away. What we need is a combination of some of the traditional language structure understanding, linguistics, and this kind of big data statistics to move forward. I agree.
One more. This has to do with machine understanding, which I would distinguish from translation. I guess the question is whether the method you're currently pursuing will also be and have machine have some cognitive consequences as opposed to simply
Sure, I think that's exactly what I was saying. So we can do a lot of translation without understanding, but even in translation, if we want to do a good job, we need this understanding. And new methods are just coming out, and this is the right time. So we have much more good databases. The computers are powerful enough. And unsupervised learning is going to be a key to this. So if you look at the same document written in 10 languages, what do they have in common? The meaning is what's in common, right? So the machine should be able to analyze a lot of that data and pull that out, but with good human linguistic direction. Yeah, that's very exciting.
Could you just say a word about the role of these tools in education? I'm thinking of things like assessment tools for computer assessment. You've talked about summarization, which is an example, but other places where you see this changing the way we teach.
Yeah, so that's a good question. So, ETS, the testing service, has a really state-of-the-art and growing research group there, and they're actively consulting with research groups all over the country to improve things. So assessment's actually a big thing. Speech assessment, how good is your spoken English, if this can be done by machines, or FBI is using assessment for how good are their translators. And this is all currently done by hand, and but within a few years that'll be automated and we can do a lot more. Some of our problems, like translation, are difficult to evaluate. Oh, repeat? Okay, so how do we, isn't there a human component to evaluating how well our systems are doing? For example, translation system. The hard part there is there's many right answers. You ask 10 people to translate a sentence, you'll get back 10 different answers. They're all right. So there's many right answers, but also many wrong answers. And so how do we tell whether it got one of the right ones or one of the wrong ones? One of the revolutions that we've had in our field is to build approximate automatic evaluators. So inside our laboratory, we can do we can tell another computer evaluate the output of this computer, and so that all becomes we can track our progress over the day or the week or the month. But in the end, of course, you have to appeal to a human to say, okay, in the end, I think it's good, and this machine thinks it's good, but is it really good? And working on ways to make that cheaper and more efficient as active area.
Yeah, one quick observation. You mentioned about, I'm over here.
Thank you.
Okay. You mentioned about sometimes you know something about where the noun is and the verb, but sometimes you have to know about who actually authored or originated the information that you're actually looking at converting to another form, say English to German. Just quickly, I had instructions for installing something, and the instructions had been translated from another language where the action was at the end. And I couldn't put the damn thing together. So all of a sudden what I did is mentally I reversed all the directions, and it worked.
You shouldn't have to do that.